Okay, so question 1 is Mary threw a ball onto level ground from a height of 2 meters. Each time the ball hit the ground, it bounced up to 3/4 of the height of the previous bounce, as shown. So the first question, A, asks, complete the table below to show the maximum height in fraction form reached by the ball on each of the first 4 bounces. So it will do 3/4 of the height of the previous bounce. So the first one bounced of 2 meters, and we can see that on the graph. So the first one is 2 meters. Then the next one is going to be 3/4 of 2 meters. So what we do here is so for the first bounce, that was for like the 0th bounce, so it's case 0. So for the first bounce, it's going to be 2 by 3/4. So that will be 3/4 of 2, which is going to be equal to 3/2. And that's it for the first one. For the second one, we do the same. So this time it's of the previous bounce, and the previous bounce is 3/2. So we multiply that by 3/4. And then that will equal 9/8. The third bounce, we do the exact same, and the previous bounce is the second bounce. So we take the 9/8, we multiply it by 3/4, and we get 27/32. Just keeping these as fractions to avoid having lots of decimal places. And the fourth one, we do the exact same thing. So we do 27/32 by 3/4, and we get 81/128. So that will complete the table for part A. So the next question asks, part B, find in meters the total vertical distance up and down the ball has travelled when it hit the ground for the 5th time. Give your answer in fraction form. So what it's really saying is if it went up by 2 meters and came back down to the ground, the total vertical distance was 4 meters. So we're just going to add them all up using the data we collected in part A. So it starts at a height of 2 meters. So we're going to have 2 meters plus, starts height, goes down 2 meters to reach the floor. Then it goes up again for the first bounce, which we found to be 3/2. And then it goes down 3/2 back down to the ground. So we're going to multiply that by 2. And then once it's at the ground, it goes back up to the height of 9/8, which we found in the previous question also. And then it goes back down to the ground from that height, so we multiply that by 2. And we continue on this pattern, just adding up all of the numbers until it has gone down to the ground and bounced 5 times. So 37/2 by 2 plus our last one will be 81/128 by 2. So once you multiply all that out and get the answer, I'm just going to give the final answer here. It's just going to be 653/64 meters. And that's the final answer. So part C of this question asks, if the ball were to continue to bounce indefinitely, find in meters the total vertical distance it would travel. So for this part of the question, we're going to need a formula. So we're going to need the formula for an infinite series, and that's going to equal the sum of an infinite series is equal to A/1 minus R. So A here is going to be the first term, and R is the magnitude, of the increase or decrease in the term in the next term of the sequence. So to give an example of that, say you had a sequence of 0.2, 0.02, 0.002, or would be equal to 1 over 10, because each term decreases by 1/10. See, the decimal place will move that way once. Okay, so we'll move and we'll use this formula then to complete the question. So part C, so we have our formula. We have S of infinity is equal to A over 1 minus R. Now, because on our graph, the ball starts like this and then does bounces like this, the first term here is irregular because it doesn't include the up motion. So we're going to start our sequence for this here. We're going to start at the first bounce. So what we do then is we just include this downward distance as just a single integer that we can add on. So we get our S infinity to be equal to 2, which is this distance here, 2 plus, so A is going to be our first term. So our first term here is, so we're taking the terms to be the whole height. So it's going to be the up plus the down of each bounce. So our first term here is going to be 3 over 2, because that's the height it gets to, by 2, because it will go up and down on each bounce. So that's going to be that. And then we have 1 minus, or the factor by which it changes. The next bounce, if we remember, is 3/4 of this bounce. So we're going to do that. So then once we work that all out, we're going to get S of infinity is equal to 2 plus, these 2's will, when you multiply 3 by 2 and then divide it by 2, they will just cancel. So we're going to do 3 over 0.25. And then our final answer is going to be equal to 14 meters. That will be the total distance that it travels as it continues to bounce. So that's question 1 completed, A, B, and C.